Hi guys, in this video I cover the circular array data structure. A circular array is a fixed size array that represents a double-ended queue. Values can be added at the front of the queue or they can be added at the back of the queue. In order to accomplish this, the circular array uses two indices. The first index tracks the front of the queue, while the second index tracks the end of the queue. Because the circular array has a fixed size, the array can become full as new elements are added. When the array is full, there are two design options to consider. The first option would block any additional add operation. The second option would override existing values in the array. This is really up to design and up to the implementation, which option best fits a particular use case. Now, there are many synonyms for a circular array. You will hear circular queue, circular buffer, double-ended queue or just DEQ, ring buffer or cyclic buffer. The C++ library provides a class named DEQ that represents and implements a circular array. The most common operations are add front, which adds a value to the front of the queue, remove front, which removes the first value from the front of the queue, add back, which adds a value at the end of the queue, and remove back, which removes the last value at the end of the queue. Now here you can see what a circular array looks like conceptually. This is a circular array that is completely full. There's no more space available for new elements. When a new circular array is created, it is empty. There are two indices, as I mentioned, front and back. Front points to the beginning of the queue, back to the end of the queue. Now, front and back could be any position because it's really just a circle. There's no particular end. Now, calling the add front function with 9 would use the front index, place the 9 at this position, and then update front by 1 to the next available spot at the front of the queue. Calling add front again with 2 would place 2 at this position, update front another time. So here we can see the beginning of the queue starts at the front index and it ends at the end index. Both front and back point at the next available position at the front of the queue or at the end of the queue. Now calling add back with 4 would place 4 at the position that back points to and then update back by 1 position. Calling add back again with 7 would place 7 at this position and then update back by 1. Now calling add front again with 8 would place 8 here and update front. Calling add back 1 would place 1 using the back index and then update back by 1. Calling add back with 5 places 5 here, update back, and calling add front with 6 would place 6 here. Note that there's only one spot left. So now calling add back or add front does make a difference if we iterate over the array, because it would make a difference if this is the first value or the last value in the queue. Now the array is full. So now calling another function such as add front or add back, let's take add front with 3 for example. This now depends on the implementation. The implementation could override the element at this position, which is 5. So it would simply replace 5 with 3, or it could block the add operation and say it cannot be added because the array is full. Now the circular array is really implemented with a primitive array. The index starts at 0 and it ends at n, where n is the size of the array. There are two indices, front and back, and then calling add front uses the front index, places 9 here, and decrements the front index. Because front was -1, using the mathematical modulo operation would place front as at size -1 at the last index of the array. Same would go with back. As we add elements to the back, if back is greater or equal to the size of the array, it would start at index 0. Now let's take a look at the implementation. This shows the implementation of the add front function. Initially, it checks if the size equals the capacity. The size represents the number of elements currently stored in the array, and the capacity is simply the length of the array. If the size matches capacity, it returns false. This shows that this particular implementation uses the block operation. It blocks any add operation from adding a value to the array if the array is full. If this is not the case, it uses the front index to access the array at that index and stores the value at that particular index. Now, given this example here, it will use the front index to store the value at this position. Then it decrements front by 1. So since this is position 0, front would be -1. That would result in this if case being true. And then it adds front to capacity and stores the result in front. Capacity is the length, which is 1, 2, 3, 4, 5. So 5 plus -1 is 4. And then it stores 4 in front. So front would now point to the last index of the array. Then it increments size by 1 to mark that a new value has been added to the array. And then it returns true that the add operation was successful. Let's take a look at the add back operation. This again checks if the array is full. If it's full, it returns false. Otherwise, it accesses the array at the back index. Currently, this would be 1. Stores the value at this position. So if we want to add, let's say 3 here, I would put 3 at this position. Then it adds 1 to back. So back would point at index 2. Then it does mod capacity. This is in case if back had pointed at the last index 4, we increment it by 1, it's 5. Now doing the mod operation, back would go back to 0, and then it would point to the index 0 here. And the result is stored in back. So back is updated to next available position. And then size is incremented as well because we store another value in the queue. And then return true. Now let's take a look at the implementation of the remove front function. This initially checks if the array is empty by comparing the size to 0. If this is 0, it returns 0. There's nothing to remove. Note that in this particular case, 0 has a special meaning. So if we allow 0 as a valid value in the circular array, it's better to return something else here. If this condition is false, it takes the front index, adds 1 to it, and mods it by the capacity. It does modulo capacity for a particular case where front points to the last element in the array. And this would be the next available spot. So using the add front operation, it would put the value in this position and then decrement front. Now, since I want to remove an operation, I have to increment front by 1 first. Then front would have an index of 5, so it would be beyond the size of the array. Then doing the mod operation, front would now point to the first index again. And then I store the resulting value of this computation in front, access the array at the index of front, which is 0, get the value, in this particular case it would be 9, and then clear that value here to 0, and then decrement size by 1, that there's 1 value left in the array, and then I return the value. So again, first checking if it's empty, then updating the front index, making sure to use the mod operation so it always stays at a valid index in the array, then getting the value at this position, removing the value, decrementing the size, and returning the value. The remove back function works very similarly. It first checks if the array is empty by comparing size to 0. If that's the case, it returns 0. Otherwise, it decrements back by 1. If it goes below 0, then it adds back to capacity. So capacity is the length of the array. Adding -1 to it would be 4, and then storing 4 in the member variable back, so that back would point now to the last index or the last position of the array. Then it gets the value stored at that index, stores it in the val variable, clears the array at that position, decrements size by 1, and then it returns the value that was removed. Now let's take a look at the performance. What is the big O complexity for these 4 functions? We have an array we use an index to go to a particular position in the array, and then we update that index. We increment it by 1 or we subtract it by 1. But it's really a simple operation, going to the array position directly without really iterating over any of the values in the array. So all of these functions have a time complexity of O1. It's very quick. Now to recap, a circular array is a simple array that has two indices. The front index tracks the front of the queue, the back index tracks the end of the queue. And if the array is full, it's a design decision if we want to overwrite values or if we want to block any additional add operations to the circular array. I hope you enjoyed this video. Thank you for watching.